All right, so this is problem 1.5.27, and they ask us to solve this right here. And whenever we're trying to solve a rational equation, what we need to do is we need to first of all factor the denominators first so that we can identify the common denominator. So this x squared minus 9 right here, I'm going to factor that into x minus 3 and x plus 3. Okay, so the LCM, or the LCD, common denominator, least common multiple, however you want to think of it, in this problem is x minus 3 and x plus 3. Now, these two are actually common denominators, and you can do it that way if you want, but most of these problems don't show that, these being common, or maybe they're not. Maybe I have that written down wrong. I'm going to check it real quick. Yeah, I have it written down wrong. Okay. So this is actually supposed to be x plus 3. All right, anyways. So what we need to do is we need to actually multiply both sides by this right here, by this LCM. And what that's going to do is it's actually going to clear the fraction for us. Okay? All right, so we'll multiply here, x minus 3 and x plus 3. And this is both of these terms here. Oops, sorry. Both of these terms here are getting multiplied by the x minus 3 and the x plus 3. Okay, so actually I think I'll write it out for you. So we have x minus 3 and x plus 3 times that first term, x over x minus 3, and then the same thing for the second term. Now the reason that I'm writing this out is this will help us because we're going to be able to show our canceling without losing anything. Okay. All right, so over here, x minus 3's will cancel, and you're left with x times x plus 3. And then here, x plus 3's will cancel, and we're left with a minus 3 times x minus 3. And then over here, x minus 3's cancel, x plus 3's cancel, and we're left with 6x. Okay, so what we're solving now is this, and we no longer have fractions in the denominator. And so if we want to solve that, what we need to do is we need to distribute the x and then distribute the negative 3. And let me get another piece of paper here. So we have x times x plus 3, 3 times x minus 3 equal to 6x. Okay, so if I take my x and distribute, I have x squared plus 3x, and then minus 3x plus 9, and that's equal to 6x. All right, so this is a quadratic, so I want to set this to 0. So these two, positive 3x, negative 3x, add to be 0. So I have x squared plus 9 equal to 6x, and then if we subtract the 6x from both sides, we have x squared minus 6x plus 9 equal to 0. Okay. All right, so we can either factor or put this into the quadratic formula. I'm just going to go ahead and factor since it does factor. So x and x, 3 and 3, and both minus signs will work there. And since these are the same, we don't need to set both of them to 0. We can just set one of them to 0 and add 3 to both sides here, and you get x is equal to 3. Now, whenever you're dealing with rational equations, you have to actually take your solution back into your original equation and look to see if it gives you a false statement or not. So x equals 3, if I plug that in, if I were to plug it in right here, it would give me 0 in a denominator. And 0 in a denominator is undefined. So we can't have x equals 3 as a solution. And since there are no other solutions in this particular problem, there would be no solution. The particular question that was asked by the student wanting this particular problem was, couldn't x equals 0 be a solution? And x equals 0 is not a solution here. It didn't come out in our process. And also, if you were to just try it, just plug in 0 here, this term goes to 0, you have minus 3. If you plug in 0 here, you would get 0 minus 3 equals 0. That would say negative 3 equals 0, and that's a false statement. So 0 is not a solution here. Okay.